Duplex strainers like this are pretty durable, and most of the time the only maintenance you'll have to perform is to clean out the baskets. But occasionally the valve that separates the two sides will wear, causing fluid to leak by the seat. Now, if this happens, you'll probably have to lap the valve seat. You may even have to replace the whole valve. Also, you may find gasket leaks, but a new gasket will quickly remedy that problem. Y-type strainers are also pretty dependable, but contaminants can get packed down, clogging the strainer. Now, if this happens and blowing down the strainer doesn't help, the only thing to do is to take the strainer apart and clean it. Sometimes installing the strainer upside down will keep it from clogging. So will frequent blowdown. The process for changing out filters is basically the same as that for strainers, with one important difference. With filters, the filter element itself is usually replaced with a new element rather than cleaned and reinstalled, like strainer baskets. And remember, if you're installing a new filter in an oil system, rub a thin layer of fresh, clean oil on the gasket. This will ensure a better seal and will reduce the chances of tearing the gasket. Filter elements made of cloth or paper are thrown away because they're generally less expensive than wire strainer baskets. And because filters can trap much smaller particles than strainers, they would be a lot harder to clean. You see, some of the particles that we have to deal with are so small that they can't be seen without a magnifying glass or a microscope. The unit of measurement that is used to describe these particles is called a micron. A single grain of salt, which you might think is pretty small, is actually about 100 microns. And compared to the size of the particles that some filters can remove, a grain of salt is enormous. Now, filters can remove particles that are only a fraction of a micron. Strainers can typically remove particles no smaller than 5 microns. Strainers, or filter elements, all have ratings that'll tell you the size of the smallest particle they can remove. If, for example, you need a filter for a fuel nozzle that has an opening of 16/1000ths of an inch, or 0.4 millimeters, the filter you put in must be able to remove particles that are smaller than the opening in the nozzle. As a general rule, if there's a critical opening or orifice that you must protect, like a fuel nozzle, the filter you use should be able to remove particles 1/2 the size of the opening. So, in our example, with the fuel nozzle, to protect a 16/1000th inch orifice, you need a filter that can remove particles that are only 0.008 of an inch. Now, this is roughly equivalent to 200 microns. Now, if you need to ensure a liquid is clear, you'll need a filter with a 25 micron or finer rating. And to remove a haze from a liquid, a 10 micron rating would probably be needed. You know, most of the time you can tell there's a strainer or a filter in a pipe simply by looking at the pipe, but sometimes you can't. This pipe, for example, has a cone strainer in it. From the outside, the only indication is this short spool connection. But in this drawing, you can see the cone-shaped strainer inside the pipe. And there's usually a spool piece in front of the cone itself. If the cone becomes clogged, the spool piece is removed first. Then the cone is taken out and cleaned. Next, we'll look at 3 special application filters in a little more detail than we've covered up till now.